All right, so now we're going to go ahead and talk about procedure 2. Our key is exactly the same as it was before. Carbon is black, oxygen is red, hydrogen is white. So we'll come back to this kind of later, but I'm going to do a reactant product chart to keep track of how many of each type of atom I have. Like I said, I'll come back to that in a little bit. All right, so I've gone ahead and already created ethanol, which has got 2 carbons, 1, 2, and 6 hydrogens total, 1, 2, 3, 4, 5, 6. Now, how you put these in order doesn't really matter, as long as you have the right number of atoms and everything has a bond filling the holes that are provided. I also have 1 oxygen, so we've got an oxygen. So this is what ethanol looks like. Okay, and then I've gone ahead and created just 1 oxygen molecule. And the reason why procedure 2 is different from what we had before is because I don't tell you how many of your reactants each you need, how many moles of reactants we need. So what we're going to do is take what we have and start creating our products. So I'm going to go ahead and start creating, let's start creating some waters here. So in its current state, I only have 1 ethanol and 1 oxygen. And I'm just going to go ahead and write the number 1 here. And obviously, we don't put that up there because we don't write 1s in our balanced equations. So I'm going to create water. Remember, I'm only allowed to use what's been provided for me. I'll just state that here. And before I totally move that over here, I want to make sure that I draw my 1 oxygen molecule so I don't forget about it later. So. Okay, I'll just set that there for right now. Okay, and I still have, now we only have 1 water. So I'm going to go ahead and just add that 1 to my chart here. Again, we don't write 1s up here for the coefficients. Okay, so I can go ahead and probably create another water because I've got this oxygen sitting here. So I'm going to go ahead and just start removing the hydrogens from the carbon, hydrocarbon. Add that here. Okay, so now I've got another water. Add that to my product side. And now I'm going to go ahead and change this. I've got 2 waters now. But we haven't completely combusted our hydrocarbon yet, and that's the goal, is to try and get rid of all of this. So the only way that we're going to be able to get rid of all of this is if we add more oxygen. So I've gone ahead and created another oxygen molecule for us. So I'm just going to go ahead and just draw this, but we don't forget about it later. And now that means we have 2 moles of oxygen. So we're going to take this next mole of oxygen and we're going to go ahead and, or this molecule of oxygen, we're going to go ahead and use it to create, I guess we could, based off of what we have left, we could probably create some more water. So I'm going to go ahead and create another water. Just like that. So now I have to change this, because now we have 3 molecules of water. Okay, but again, I'm still not completely combusted here. I still have a little bit left, and I have an extra oxygen. So based off of what I have, what can I make? It doesn't look like I have any hydrogens left, so I guess I'm going to have to start making CO2. It looks like I have 2 carbons, and you only need 1 carbon for CO2, so that means I'm going to need to use at least 2 CO2s. So I'm going to go ahead and use this carbon here, and use one of my oxygen molecules to create CO2. There's steal a bond from this one. Okay. Oops. All right. Just like that. So now we've created a CO2 molecule. I'm going to go ahead and add that to my chart. We only have 1 over here. Now, we're kind of running out of, we ran out of like our picture. So I'm going to go ahead and just draw our ethanol molecule over here. So this is what we started with, right? Okay, so now as you can see, I'm left with only one carbon left, and I need to fully combust this, and clearly I have not fully combusted this. So the only way I can combust this is if I add another oxygen. If I add another oxygen, then I'll have two oxygens to create another CO2. So I've got an oxygen molecule here. I'm going to go ahead and draw my third oxygen molecule. And that means I now have 3 oxygens. So we have to change the coefficient to 3 up here as well. And we have a bond between those 2 oxygens, right? And I'm going to go ahead and create carbon dioxide because I can't create hydrogen. And remember, everything has to go around that central atom. And now I've created another carbon dioxide. Because I've done that, I have to change my coefficient here. I've got 2 of those. Okay, so of course you're going to go ahead and draw these molecules much like you did over here. And you can see that the reason why this works, or the reason why we're doing this, is to show that you can only use the atoms that are provided for you here in order to create these products in this amount. This is just essentially showing you how mass is conserved from reactants to products. And it also just shows you a more visual representation what goes on when you balance a chemical reaction. So for instance, you can see here we've got 1, 2, 3, 4, 5, 6, 7 oxygens over here. We've got only 2 carbons, and we've got 6 hydrogen. If you look over to the product side, we have 1, 2, 3, 4, 5, 6, 7 oxygens, 2 carbons, and of course 6 hydrogens. So if it's easier to just balance these at first, that's fine. But realize that what's happening is we're taking what we have originally, right? We had to add a few oxygens in here to completely combust this. But in order to get these products, we need to have 3 moles of oxygen and only 1 mole of ethanol in order to get 2 moles of carbon dioxide and 3 moles of water. So this last portion here we need to calculate. And this is just trying to calculate the total number of kilojoules of energy per mole. So on our chart, we are already given 1,235 kilojoules total is released after we burn this or combust this hydrocarbon ethanol. It's actually an alcohol type. So we've got 1,235 kilojoules. Now, how on earth are we going to get this to the amount that is released per mole? Well, we only have 1 mole of fuel. So if you look at the units on your table, you'll see that it already says kilojoules per mole, kilojoules divided by moles. So this is our formula. So we're going to go ahead and just take what we have here and divide it by how many moles of fuel we have. We only have 1 mole of fuel. So that's 1 mole of C2H5OH, which gives us 1,235 kilojoules per mole. And that's what we'll write right here. Now, numerically, it's the same, but the units are different. So you can see that per mole, we have actually 1,235 kilojoules per mole are released per mole of this fuel.